Okay, so today we will talk about the first part for the quiz for review list. Okay, quiz for review. So this part we will talk about all the questions that are related to the right triangles in the xy plane. Okay, in the xy plane. So we have different questions, different topics about triangles in the plane, but mainly is about these two right triangles. Okay, you have to remember the angles, the sides, how to label them for 30, 60, and 45-degree right triangle. Right, so if you use reading measure, so this will be pi over 6, this is pi over 3, this is pi over 4. Okay, pi over 4. Okay, so now I first draw the 30-60. Okay, the 30-60. And how to remember the side, how to label the side, we use opposite side. Okay, opposite side. You go inside the triangle, you go opposite side of 30, that's length 1. Opposite side of 60-degree, pi over 3, that's radical 2, and the opposite side of the right angle, so this is hypotenuse, which is number 2. Okay, number 2. So you remember opposite of 30 is 1, opposite side of 60, this is radical 3, and then hypotenuse is 2. Okay, is 2. Okay, yeah, so this is the way to write down all the three lengths of 30-60 right triangle. So the other one is easier, and then I will give you two models. Okay, two models. So I like the first one. So this is 45 degree. You have the same acute angles in the right triangle, so they have the same opposite side, same length 1. So opposite of this bottom 45, 1. Opposite of this top 45, 1. And then hypotenuse is radical 2. Okay, radical 2. Okay, yeah. So opposite of 45 degree is 1, and then opposite of hypotenuse, opposite of 90 is radical 2, so which is called hypotenuse. Hypotenuse is radical 2. Okay, radical 2. So now there is another model for this 45. So they will use radical 2 for the opposite of 45 degree, and then 2 as the hypotenuse. Okay, 2 as the hypotenuse. Okay, so they are equivalent models. Okay, they are equivalent models. Okay, yeah, so this is how we label the right triangles. Okay, label the right triangles. And then you have to understand, you have to remember the definition of sine, cosine, and tangent. And then flip them, you got the other three, right? The other three. Okay, so now I will write down the definition of sine, cosine, and tangent on top of this page. Okay, on top of this page. Okay, yeah, so now sine theta for any angle, right, is the opposite of angle theta over hypotenuse. Cosine theta is adjacent side of the angle theta over hypotenuse, and then tangent is opposite over adjacent. Okay, opposite of adjacent. So now let's look at the triangles, right? These two triangles. Okay, yeah. So let's see what's sine 30, cosine 30 for the 30 degree, right? For the 30 degree. Okay, so let's look at if theta is 30. Okay, theta is 30, so now this number 1 definitely is the opposite side, right? Opposite side. And hypotenuse doesn't depend on you looking at 30 or 60. Okay, so hypotenuse is 2, opposite is 1. Sorry, yeah, hypotenuse 2, opposite 1. And then adjacent side has to be radical 3. Okay, radical 3. Okay, so for this angle 30, opposite 1, hypotenuse 2, adjacent radical 3. So now what's sine? Sine for 30. This will be opposite 1 over hypotenuse 2, right? Cosine 30, this will be adjacent over hypotenuse. So this is radical 3 over 2, right? And then tangent is opposite over adjacent. So this is 1 over radical 3. Okay, 1 over radical 3. Okay, yeah. So now let's look at 60. Right, let's look at the angle 60. Okay, 45, 45. You can do it as an exercise. It's easier because the same length, right? Because the same length. So now I will use a different color. I will draw the same triangle. So now this is 30, 60, and then radical 3, 1, 2, same length. So now we focus on the opposite of 60. So for angle 60, if the angle is 60, then the opposite side will be radical 3, and then hypotenuse is still 2. So this number 1 has to be adjacent side. Okay, adjacent side. Okay, so it's called adjacent side because that side is a part of the angle 60, that part next to the angle 60. Okay, next to the angle 60. Okay, so then sine 60 is opposite over hypotenuse. So this is radical 3 over 2. Cosine 60 is adjacent over hypotenuse. So this is 1 over 2, right? And tangent 60 is opposite over adjacent for 60 degree. And then this is radical 3 over 1. Okay, over 1. So now if you're not familiar with trig, put opposite adjacent side and hypotenuse first, and then find the trig value. Okay, so trig value is just the ratios of the side of right triangle. Okay, of right triangle. Okay, yeah. So now let's look at the first question, the first two questions in our review list. Right, review list. So number 1, we got cosine 45 plus sine 30 minus cosecant 45. Okay, 45. Okay, so now when you solve these questions, I need to see the two right triangles. Okay, two right triangles. So let's keep them here, right? Again, 30, 60. So this is 1, radical 3, and 2. And then 45, 45. 1, 1, radical 2. Okay, 1, 1, radical 2. Okay, so now cosine 45. Okay, cosine 45. So you can label the opposite, right? Opposite 1, adjacent 1. So cosine is 1 over radical 2. Hypotenuse radical 2. Plus sine 30. So we are looking at this angle 30. Opposite 1. And then hypotenuse 2. So 1 over 2. Okay, 1 over 2. So now cosecant. So what's cosecant? Cosecant, you may change it to, you have to change it to sine, right? So cosecant 45 is 1 over sine 45. Okay, or you can think you find sine 45 and then flip it. You got cosecant 45. Right, so what's sine 45? Sine 45 is 1 over radical 2. So now you flip it. You got radical 2 over 1. Okay, it's the reciprocal relation or flip relation. Okay, flip relation. So now we got radical 2 over 1. Okay, radical 2 over 1. So I need to see the pictures, and then I need to see the ratios. Okay, ratios. So now if you can, right, the next step is optional. If you can change them to common denominator 2, right? So this multiplied by radical 2, this multiplied by 2 and 2. So this is radical 2 over 2 plus 1 over 2. Oh, sorry, the last one is minus here. I put the wrong sign. Minus, right? So it's minus 2 radical 2 over 2, right? So now you get the same denominator. So radical 2 plus 1 minus 2 radical 2. So this is 1 minus radical 2 over 2. Okay? So simplify or combine the ratios is optional. Okay? Optional. Okay? Yeah. So that's number 1. Okay? That's number 1. So now number 2. Number 2 is similar. So I will keep the right triangles. Okay, I will keep the right triangles. Okay, so number 2 is tangent 30 times tangent 60 minus tangent 45, right? So what is tangent 30? We're still looking at this purple line, right? That's opposite of 30, so opposite over adjacent, so 1 over radical 3. So now for the 60, so let's use green color. What's opposite of 60? Radical 3. So tangent 60 is radical 3 over adjacent 1, right? Over adjacent 1. Okay, so it's 1 over radical 3 times radical 3 over 1. And then what's tangent 45? Tangent 45, so let's use blue color. So 45 is this 1. So tangent is 1 over 1, opposite over adjacent. Two sides has the same length, right? Same length. Okay, so you can leave this. This is a good answer for me. Or you can simplify this a little bit. So now you see radical 3 cancel. So we got a 1 minus 1, which is 0. Okay, which is 0. Okay, so this is the basic trig questions for right triangles. So now we will put right triangles. We will draw right triangles in the plane. Okay, in the plane. Okay, so let's write down the key point on the top. So we need a point on the terminal side. On the terminal side of the rotation. Of the angle, right? And draw a vertical line. From the point, okay, from this point. Or passing through this point. Okay, so now what's our vertical line? Our vertical line is go up and down, right? Go up and down. Okay, so now let's look at the first question that we need a right triangle in the xy plane. Okay, xy plane. So for this question, they give you the point P. Okay, yeah. So if the terminal side of theta passes through the point P, which is -3 and 4. Okay, so there's a point on terminal side, right? They want us to find sine theta, cosine theta, and tangent theta. Okay, tangent theta. Okay, so let's draw the triangle first and then rewrite the definition of sine, cosine, tangent using XYR. Okay, using XYR. Okay, yeah, so now let's draw the picture first. So first, where is this point P? This point P is -3 and then 4. So this is the point, right? Okay, so this is point P, and then the terminal side is P is on the terminal side of the angle, so this is the terminal side, the green side. So this is the angle. The rotation starts from positive x-axis to this green line, okay, to this green line. So now the important thing is we draw a vertical line, up and down line, passing through P to make a right triangle, okay, to make a right triangle. So now we can label the three sides of right triangle using x, y, and r. So here r is square root of x squared plus y squared. R is always positive. Okay, r is always positive. So now let's label x, y, r. X is -3, y is 4, and then r is 5 using Pythagorean theorem, right? So r is square root of x squared plus y squared. So this is -3 squared plus 4 squared. This is 25, square root of 25, 5. Okay, 35. So now what is sine, cosine, and tangent, right? What is sine, cosine, and tangent? So sine theta will be opposite of the reference angle, okay? So sometimes in some book they use alpha. So it's the acute angle in the right triangle that was the center, that was the vertex at the origin 0, 0. Okay, so opposite of this alpha is 4. So y over r is opposite over hypotenuse for this angle alpha. Okay, for angle alpha, for the reference angle. Okay, yeah. And then this is 4 over 5. And then cosine theta is x over r is adjacent over hypotenuse for angle alpha. So this is -3 over 5. Okay, -3 over 5. And tangent is y over x. So this is 4 over -3. Okay, 4 -3. Okay, so for angle alpha, this is opposite of alpha over hypotenuse. This is adjacent of alpha over hypotenuse, and this is opposite over adjacent. Okay, for this angle in the right triangle. Okay, in the right triangle. Okay, so this is the connection. First, we know what's the definition in the right triangle. Now we know how to do it in the xy plane. Okay, in the xy plane. Okay, so if you are given a point, this is the easiest case, right? This is the easiest case to draw a vertical line to get the right triangle. Okay, so now the next question, they said, okay, so we know cosine theta is 2 over 3, and sine theta is less than 0. Right, less than 0. So they want us to find sine theta and tangent theta. Okay, tangent theta. Okay, so now for this question, again, we need to draw the triangle, right? We need to draw the triangle. Okay, yeah. So now, let's first write down cosine theta is 2 over 3. So this is x over r. Then we know x is 2, r is 3, right? R is 3. Okay, so now we also know sine is less than 0. So sine theta is y over r is less than 0. So r is always positive, right? So that means y is less than 0. So x is 2, y is less than 0. We got the picture in the, so this is point at P, x, y, right? X is 2, and y is less than 0. So P is in the fourth quadrant. Okay, and then that's the terminal side, right? This is the terminal side of the rotation, the red line. Okay, the red line. Okay, yeah. So first you know the picture is look like this. Okay, you find P in the fourth quadrant, and then you draw a vertical line passing through P. Okay, up and down line, right? To make a right triangle. Okay, make a right triangle. Okay, so write down P is x is 2, and then y is less than 0. Okay, less than 0. Okay, so now we have a right triangle. So now the problem is, and then we also know r is 3. So now we need to find what is this y, right? What is this y? Using Pythagorean theorem. So we know 2 squared plus y squared is 3 squared. So 4 plus y squared is 9. Y squared is 5 minus 4, right? Move it. 9 minus 4 is 5. So y is square root of 5, or y is negative square root of 5. Take square root. Okay, take square root. And we know y is negative, so it's negative square root of 5. Okay, negative square root of 5. Okay, so now we know x, y, r. So x is 2, r is 3, y is negative 5. Or you can use the picture. Then we know sine theta is y over r, so it's negative radical 5 over 3. And tangent theta is y over x, so this is negative radical 5 over 2. Okay, over 2. Okay, so you use the given information. You can see x is positive or negative, y is positive or negative, and then you know where is this point P, right? Where is this point P? And then it's on the terminal side, so you know where is the terminal side, and then draw a vertical line to make a right triangle. Okay, make a triangle. Okay, so we will do this a lot. Okay, all the questions in this lecture video, you need a right triangle. Okay, you need a right triangle. Okay, so now let's look at the next one. The next one, they want to find cosine 5 over 4 pi. Okay, 5 over 4 pi. Okay, yeah. So now if you're not familiar with reading measure, you can use degree measure, right? Degree measure. Okay, so 5 over 4 pi, change to degree measure. So this is 180 over pi. You use, so this is pi canceled. Then you got 45 times 5, 225 degree. Okay, 200. So this is cosine 225 degree. Okay, 225 degree. Okay, yeah. So now let's draw the picture. Where is this terminal side, right? Where is this terminal side? Okay, so now let's use radian measure because they give us radian measure, right? So this is pi, right? This is pi over 2. This is 3 pi over 2. Okay, so 5 pi over 4 is between pi and 3 pi over 2. Okay, 3 pi over 2. Okay, yeah. So 5 pi over 4 is pi plus pi over 4, right? Yeah, so this actual rotation after pi is pi over 4 is 45 degree. Okay, 45 degree. So if you use 2 to 5 degree, so this is 180 plus 45 degree. Then we got the same place, right? Same position. Okay, same position. Okay, so now you choose a point P on the terminal side, and then you draw up-down line, vertical line to make the right triangle. Okay, right triangle. So now we can label the three lengths using our special right triangle, right? So remember we have 45 degree right triangle, right? So this is 1, radical 2. But now it's in the xy plane, so x is -1 because it's on the left, and the y is -1 because it's in the lower half plane. Okay, and the r is always positive. Okay, r is always positive. Okay, yeah, so now what's cosine? Cosine is adjacent of this reference angle 45, the acute angle in the right triangle with vertex at the origin. That's the reference angle, right? Then we got adjacent over hypotenuse or x over r. So this is -1 over radical 2. Okay, -1 over radical 2. So we used the right triangle. Okay, yeah. So now let's do sine -45 degree. So this is easier for some students because they give you a degree measure, right? Degree measure. So now this is 45 again, but this rotation is -45 because it's clockwise rotation. Okay, so now from any point P on the terminal side, you draw up-down line, you got right triangle. So now x is 1, y is -1, and then r is radical 2. Okay, so now this time x is positive because it's on the right. Okay, on the right. Okay, so now what is sine -45? This will be 1 over r. So this is -1 over radical 2. Okay, -1 over radical 2. So this is the first page of the river list, right? First page of the river list. Okay, yeah. So now for the inverse function and the trig equation, we also need this kind of pictures. Okay, this kind of pictures. So I know I'm not going to solve all of them. I will pick some questions. Okay, I will pick some questions because there are 6 trig inverse. There are 6 trig inverse. Okay, yeah. So now let's look at number 1 for the trig inverse. So let's say find sine inverse of radical 3 over 2. So I will do a positive ratio, a negative ratio, and then I will do the special point, special value, 0, 1, -1. Okay? Yeah. Okay, so now for this inverse trig. So first we change it to trig, regular trig function, right? You put an angle. The answer for the inverse trig is the angle. We are looking for the angle, right? So we are looking for the angle theta such that sine theta is radical 3 over 2. Okay? So the understanding for the trig and inverse trig, you have these two things, the angle and the ratio. Sine function, change angle to ratio, and then sine inverse, change the ratio to angle. Okay, change the ratio to angle. Okay, yeah, so that's the relation. Okay, that's the relation. Okay, so now after you change sine inverse to this sine function, then we know sine function is y over r, right, by definition. So next step is the picture, right, is the picture. So y is radical 3, r is 2, right, r is 2. Okay, so now what about x? X is positive or negative? So now you need to know by the definition of inverse trig, our picture only has 1, 2, and then 4. These choices for the picture. Okay, picture. Okay, yeah, it's in the quadrant 1, quadrant 2, and quadrant 4. We don't have quadrant 4. Okay, we don't have quadrant 4. Okay, yeah. Okay, so now it's in 1 and 2. So for positive sign, it's in, this is for positive, all the positive inverse trig. It's in the first quadrant. Okay, if the ratio, this ratio is positive, you draw the picture in the first quadrant. Okay, yeah, for negative, you may get 2 or 4. Okay, 2 or 4. So if cosine is negative here, if sine is negative in the fourth quadrant, right? Yeah. And if tangent is negative, so I think it's also in the fourth quadrant. fourth quadrant. Okay, yeah, so let's write it down. So this is cosine is negative. You draw it here. Sine is negative, or tangent is negative. Okay, tangent is negative. Okay, so this is where you draw the right triangle. Okay, right triangle. So now we got sine is positive, so our picture is here, the right triangle. So this is the point P, right? This is point P. Okay, so now we know x is positive. So this is radical 3, 2. So now what's the last side? 1, right? 1, 2, radical 3, right triangle. So this is 60, 30, right triangle. So here we still need our special 30, 60 or 45, 45, right triangle. Okay? Yeah. So now we know x is 1. So if you forgot, you can use Pythagorean theorem to find x. You get same number 1. Okay, same number 1. But you have to know first it's in the first quadrant for all positive inverse trig value. Okay, inverse trig value. Okay, so now what is the angle? The opposite of radical 3 is 60, so theta is 60. Okay, so the answer is 60 angle. Okay, angle, not the ratio. Okay, not the ratio. Okay, so now if you change this to negative radical 3 over 2, right? So that's question 2. So if this is sine inverse of negative radical 3 over 2, then what do we got? Okay, then what do we got? So we know sine inverse, so we put this is equal to theta, then this means sine theta is negative radical 3 over 2, then we know y over r is this, so y is negative, r is positive, right? So now I already explained sine and tangent when they are negative, we have the picture in the fourth quadrant, so picture is here, right? So here is 2, and then we got negative radical 3, so this is 1, right? This is 1. Okay, so from the ratio you got the picture. From the picture you know this is a negative rotation, and then opposite angle is 60, so theta is negative 60. Or you can use the other side of the positive rotation, right? Positive rotation, that's also okay with me. So you will get 300. Okay, you will get 300. So this is 300 positive rotation, and if you rotate it this way, negative rotation, you get negative 60. Okay, negative 60. So 60 is the angle, positive 60 is the angle in the right triangle. And then if you put directions, then you got positive or negative angle answers, different answers. Okay, yeah. So this is for sine, right? This is for sine. So now let's jump a little bit. If this is cosine, right? Cosine negative, cosine inverse of negative radical 3 over 2. Okay, so now you know the position is in the second quadrant, because cosine is negative, right? So x is less than 0, y is bigger than 0, r is bigger than 0. Okay, so first you know where is the position of the right triangle. So now let's change it to cosine function. Okay, so cosine is x over r, so x is negative radical 3, r is 2. So now based on the special right triangle, you know y is 1, right? So this is negative radical 3, positive 1, 2, right triangle. So now what is this angle? This angle will be 30. Opposite to number 1, right? This is 60. Opposite to radical 3, right? Radical 3. So now how big is the angle theta? So this angle theta will be theta plus 30 degree. The alpha is 180, the half circle. So theta is 150. Okay, theta is 150. Okay, so theta plus 30 is this half circle, which is 180, right? Which is 180. Okay, yeah. So that's the right triangle case. Okay, that's the right triangle case. Okay, yeah. So now for number 3 and number 5. For number 6 is similar. Okay, you can practice, and then the answer for number 6, for question 6, let's just put it here. Cosine inverse of 1/2. The answer is 60 degree. Okay, 60 degree. Okay, you can draw a picture. Very easy picture. 2, 1, radical 3. So this is 60. Okay, 60. Okay, so now for number 3 and number 5. Okay, so let's put them together here. They want sine inverse of 1, and number 5, they want cosine inverse of 0. Okay, cosine inverse of 0. Okay, yeah. So they are not 1, 1 radical 2 or 1 radical 2, 1, 2 radical 3 right triangle. Okay, if you see 0, 1, or -1, you should use those 4 points on the unit circle. Okay, so which 4 point? P1, 1, 0, P2, 0, 1, P3, -1, 0, and P4, 0, -1. Okay, so they are on the unit circle, and they are the solution for the inverse trig if you are trying to find the inverse trig function for 0, 1, -1. Okay, inverse trig value for sine cosine. Okay, for sine cosine. Because for any point on the unit circle, r is 1, so y will be sine theta is y over r, so is y over 1 is y. So sine is y, cosine is x over r, so this is x over 1 is x. Okay, x. So now we know, let's change the color. So this will be cosine 0, the rotation 0 degree. This is sine 0, right? And this is sine 90. This is sine 180. A cosine, sorry. So the x coordinate are cosine. Y coordinate are sine, right? So this is cosine 90, cosine 180, and cosine 270, right? 270. So now let's change to green color. So this is sine 0. We already write it down. So now this will be sine 90, and this is sine 180, and this is sine 270. Okay? Yeah. You see, that's how we find the inverse angle, the inverse trig function, the angles for 0, 1, -1. Okay? So for number 3, we need sine inverse of 1. So that means if this is angle theta, we got sine theta is 1. So which one give us sine theta is 1? 90 degree, right? 90 degree. So we use point P2, that give us theta is 90 degree. Okay, so now cosine is 0. So this is cosine inverse of 0. So this means cosine theta is 0. So which one cosine theta is 0? It's still the same point P2. So that gives us theta is 90, right? 90. So if they said, okay, let's find sine inverse, so let's add a number 7, right? Sine inverse of -1. So if this is the theta, so we got sine theta is -1. So which one in this picture give us sine is -1? 270, right? 270. So P4 give us sine 270 is -1, so theta is 270. Okay, 270. So this is the special case. Okay, you cannot use right triangle. You have to use unit circle to find the inverse trig value. Okay, so now the last topic in this lecture is equation. Okay, is equation. So you solve linear quadratic equation and then you find inverse trig value. Okay, inverse trig value. So that's very similar to the inverse trig part. Okay, inverse trig part. So in the class I solved 5 and 7. Now I solve 6 and 8. Okay, I will solve 6 and 8. Okay, so now 6 we got sine squared is 3 over 4. Okay, so my suggestion is we use a new letter for the trig function, right? So suppose t is sine x. Okay, a new variable t. Then we got t squared is 3 over 4. So you take square root. T is square root of 3 over 4, or t is negative square root of 3 over 4, right? So simplify a little bit. This is radical 3 over 2. Square root of 4 in the bottom is 2, or t is negative radical 3 over 2. Okay, over 2. So we solve the quadratic equation for t, and then we got two solutions, t1 and t2. Okay, so this has nothing to do with the trig, right? With the trig. And now we put the sine back. Okay, so we got sine theta is radical 3 over 2. That's first angle, theta 1. And then sine of second angle, theta 2 is negative radical 3 over 2. Okay, so now it's the same situation as inverse trig, right? Inverse trig. Okay, so one understanding, you can write down the solution. Theta 1 is sine inverse of radical 3 over 2, and theta 2 is sine inverse of negative radical 3 over 2. Or you can solve it as our first and second example in the trig inverse part, right? So where is this? This is radical 3 over 2 y over r, so this theta is 60. So theta 1 is 60. And then this one, we know sine is negative, so y is negative. This is y, this is r, right? This is negative radical 3, 2, 1. So this will be 60 again, so theta 2 is negative 60. Okay, negative 60. Okay, so for me, both answers are acceptable, but this is good. Okay, this is better. Theta is 60, theta is negative 60. They are better solutions. Okay, better solutions. So you either use inverse trig notation for the answer, or you use the picture to get the angle. Get the back angle. So now number 8. Okay, number 8. So let's put number 8 in the trig equation part. The last question in the review list, right? In the review list. Okay, so next video I will talk about the graph and identity. Okay, so this video let's focus on the angles. Okay, yeah, so if you let t equals sine theta, and again new angle, a new letter, sorry, so this is t squared plus t is 0, so factor t times t plus 1 is 0, right? So now you solve two linear equations, t is 0 or t plus 1 is 0, so you got t1 is 0 and the t2 is negative 1, two solutions for the zeros, right, for the zeros. So now let's put sine back. So this is sine theta is 0, theta 1, or sine theta 2 is negative 1, right? So now use inverse notation. So theta 1 is sine inverse of 0, and the theta 2 is sine inverse of negative 1. Okay, negative 1. So now if you like, you can draw the P1, P2, P3, P4 again. This is 0, 1, negative 1, right? So we need these 4 points, right? We need these 4 points. P1 is 1, 0. P2 is 0, 1. P3 is negative 1, 0. And P4 is 0, negative 1, right? Negative 1. And now we need sine value, right? Sine value, so x is cosine, y is sine on the unit circle. So we need this part. This is the sine, right? This is the sine. So sine is negative 1. So that means we need P4. So this is theta 2 is, this is sine equals negative 1, right? Sine 270. This is 270, P4. And then sine equals to 0. Where sine is 0? P1, right? P1. Okay, you can also use P3. Okay, also use P3. P1 is 0, so this means theta 1 is 0 degree. Okay, P1, there's no rotation for P1. Okay, so that's it. That's our first review video for the quiz 4. So there will be another one which has graph and identity. Okay, graph and tree identity.